Hello and welcome back to Data Services Office Hours. I'm your host, Frank Lavinia, the Global Go-to-Market Lead for Data Services here at Red Hat. Last time, we spoke about rockstars and roadies, which is basically the notion that data scientists are rock stars, but like rock stars, they need the skills and talents of a whole team of folks with other skills, such as electricity, carpentry, sound engineering, and the like. This week, we're going to talk about a fundamental component to the success and possibly even the existence of any data project. Whether it is the latest in large language model development or a good old-fashioned CSV file sitting on a file share. And that component is storage. Yes, storage. Storage is fundamental to any data project because without storage, there's nowhere to store data. So with that in mind, let's take a closer look at IBM Storage Fusion. Take it away, Randy.
Hey everybody, my name is Randy Arsenault. I am a product manager and business development guy in the IBM Storage brand, and I'm here to take 5-ish minutes probably today to give you a quick intro on IBM Storage Fusion before we get into the better part of the session later on. So thanks for joining, and let's get right into it. So I want to start off by talking a little bit about Fusion, what it is specifically. You may have heard about it, you may not have heard about it. I want to give you a quick overview of what it is. We're going to talk about kind of why it exists and why we created it and what its kind of direction is. And finally, who it's really for and who the primary users are. So let's go ahead and dive a little bit into what Fusion is. So Fusion is a software product predominantly, although it is available in two form factors, both as a software solution as well as a pre-built, pre-integrated appliance. So you'll see those two things here. They share some commonality. They have a common console, similar data protection story, similar disaster recovery story, and the same data foundation, which incidentally is OpenShift Data Foundation. Folks may know that as of January 1st, the OpenShift Data Foundation and Ceph business lines moved from Red Hat into IBM. So they are now IBM products. So we're going to be kind of gradually rebranding ODF to be Fusion Data Foundation, same solution. So think of Fusion as inheriting all the great stuff that ODF has and then adding more stuff onto it, which is a good story. So it supports a lot of different platforms. It's designed to be a very robust container native data services platform for any OpenShift application. It supports our cloud packs, of course, but it also supports anything that runs on OpenShift. And it can be deployed across any number of infrastructural kind of foundation layers, whether it's on-prem or in one or more public clouds. You'll see the supported platforms on the bottom of this graphic here. And the difference, again, the fundamental difference, and it's significant, but it is the same software stack, but the appliance is a fully integrated appliance. It includes compute, storage, and networking, all pre-built, pre-integrated with a management console. You wheel it in, you zone it into the network, you plug it in, you're up and running in 4 or 5 hours. So it's a really, really compelling kind of value proposition in terms of time to value, very popular for enterprise customers that are looking to deploy big and many OpenShift clusters. So the HCI flavor is targeted, again, primarily at sort of platform engineering folks and people that are looking to scale out OpenShift in the enterprise. They want to accelerate application delivery. They want to make sure that they're providing a cost-effective and cost-optimized platform to run mission-critical OpenShift workloads on-prem typically. They want to de-risk the deployment model. Now, there are a lot of challenges associated with some of these larger organizations that are refactoring and migrating their workloads from a legacy platform into OpenShift, into a containerization environment. They want to be able to have consistency. They want to make sure they have high availability, data protection, data sovereignty, all the things they used to have. They want to make sure they have to have those things going forward. And they need to ensure that in this new platform environment, they've got all the same things. So Fusion is really designed from the ground up to deliver that at enterprise scale. So help customers accelerate their deployments of multiple clusters, even very large clusters. We've got customers that are running thousands of cores of OpenShift, some pushing 1 million cores, amazingly. And this is a really, really good platform to help them scale those out. The big advantage of Fusion is that we provide a single support contact. So for enterprise customers that want to deploy again on OpenShift, they can pick up the phone and call IBM. They have one call. We will do the triage. We'll take care of the level 1 and level 2 support, bring Red Hat in as needed. But again, it's a great and very safe and secure way for them to deploy these enterprise-grade applications. We can, again, supplement and augment what's already available in ODF with some additional levels of data protection and data resilience, which you're going to see a little bit later on in the demo session that Josh is going to take you through. And of course, supported for IBM Cloud Paks, but again, any OpenShift application can run on this platform, no problem at all. Now, the software version, again, it's the same code base. The software version is designed to be deployed either on-prem, typically on a bare metal, server. It can also be deployed as a client-managed or ultimately fully managed service on one or more public clouds. You saw the platform support a little bit earlier on. But again, the same goals are in place here, the same objectives. Help customers deliver applications faster and more predictably, more reliably, help them really get the full benefit of OpenShift, being able to write their code in one place and then deploy and run it anywhere, and really simplify the container native storage consumption by developers. So give them the services they want as operators and CRDs that they're already familiar with, so they don't have to go worry about infrastructure or RAID groups or LUNs or data protection or all that stuff. They don't care about that. They can just write code. So again, we provide a turnkey experience here. It's consistent across platform. Doesn't matter where it runs. All validated both with our own stuff and third parties. We're working very closely with ISVs and others in the space to ensure that as customers look at the thousands of available open source and commercial software products, that they're going to run no problem in this environment and be fully supported. There was some survey data that was published recently by an independent analyst group. This was not commissioned work. This was done as a survey and market data, and they found that Fusion, soon to be Fusion, currently OpenShift Data Foundation, is the number one deployed data services platform for Kubernetes by a pretty significant margin. You can see some of the competitors here. We've got a pretty significant lead. Probably not surprisingly, a lot of people are using ODF alongside OpenShift. Makes sense. Built together, designed to interoperate very cleanly and efficiently and effectively. We're stretching out this lead. We plan to continue stretching out this lead, and we're going to continue to support, obviously, upstream open source with both the ODF and Ceph products. And we're going to continue to deliver this advanced functionality and innovation and enterprise-grade, hardened data security, data resilience, data protection into the Fusion space. I'm not going to read through this whole thing. The point here is that, the audience that we're selling to is a pretty diverse audience. It's really anybody running any OpenShift application. There are some interesting emerging trends like Red Hat OpenShift data science, where we're seeing great uptake. The fact that Fusion can support GPU accelerated computing, working with NVIDIA, our partnership with NVIDIA. But you can see there's a bunch of applications here. But this is just to reiterate that the challenges that our customers are dealing with, time to market, cost efficiency and cost optimization, data security, agility, we're here to kind of help them. IBM and Red Hat together have, 100 plus years of expertise in this space, helping customers overcome these issues and develop and deploy and deliver at scale these next generation workloads. So great scalability. We support bare metal for customers that are looking to move away from a hypervisor-based deployment model because they want to save money. They want to reduce the number of layers of abstraction in their infrastructure stack. Bare metal deployments of OpenShift are great for that, and this is a great way to get there. Great application-aware backup and recovery, all delivered as standard operators and custom resource definitions, so easy to consume by developers and CI/CD pipeline folks. And it's, we think it's better than the competition for a bunch of reasons. Again, that one call full stack support model is great. Scales exceptionally large. The HCI appliance is built on our world-class clustered file system that was born out of high performance computing and is now very commonplace in the enterprise. But again, we also support, of course, ODF and external Ceph clusters as well. Great Cloud Pak support for those customers that are running our Cloud Paks, and again, built on the number one Kubernetes data services solution in the industry. So that's a very quick overview of what it is, kind of why it is, who it's made for. We'll get into the good part of the presentation now. QR code there is me. If you want to pause here and zap that, you can contact me if you have any questions or any follow-ups. But with that, I will turn it over to Josh and company to take you into the good parts. Thanks.
So now I'd like to explore some of the advantages of using the data services of IBM Storage Fusion for protecting our environments. In this particular instance, we have an OpenShift cluster running with IBM Storage Fusion installed, providing data services. Here we can navigate to the IBM Storage Fusion welcome screen, and we can see the data services we have. We're going to focus in on the ability to do backups and restores for this particular discussion. If we click on the backup icon, we can see we have policies defined for doing backups. We have two particular types of policies defined. We have a snapshot policy that does a snapshot in place, and that one will run as long as the underlying storage technology supports snapshots. It uses the CSI interface to take a snapshot in place. And if there are multiple persistent volume claims defined for an application, it will do a crash consistent copy across all those persistent volume claims. And then we have a full backup. In the case of the full backup, we'll take a snapshot, and then once we've taken our snapshots, we send the data of that snapshot along with the state of the application, all the resources that application uses, and send that to an S3 bucket. If we look at locations, we can see an external S3 location that I've defined. Here's the S3 environment. If I click on it, I can get the details. We can see the URL for that S3 location. We can see the name of the backup, and this has been associated with a particular policy. Now, if we click back on the policy tabs, if we want to create a new policy, we'd click on Create Backup Policy. We can choose the frequency of the backup. We can choose when the backup will occur, and we can choose the backup type, whether it's a snapshot in place or we're sending our data to an external object store. And then if we do want to send it to an external object store, we can have a number of remote locations defined, and we select the one we want to use and create that backup policy. We'll cancel that because we've already done that. Then once we have a backup policy, we can apply it to applications. So in this case, when we think about applications, we're looking at namespaces or projects within our OpenShift environment. And here we can see all the different namespaces of our environment. We can actually set a filter to only look at newly created ones, only ones that actually have snapshots or completed backups done, or that have policies defined. So if we're looking to create a policy for an environment that has no policy defined, we can check the no policy button and filter out the ones that already have policies. If we come back to our OpenShift environment, those are projects. We can take a look at our projects by clicking over to our workloads and then seeing all the different projects that are out there. We're going to focus in on a data science project we've been working on, and this particular project is a project where we're doing AI learning of recognizing license plates. So we'll come back and say we're going to run a backup of this particular environment. Actually, we can go and look and see the storage. So we have two ways of seeing what types of persistent volumes are being used. We can go down in the project and click on persistent volume claims, and we see the associated persistent volume claims. Or we can come over here back to the application space. We can select our project from here because it's as referenced as an application. And then we can take a look at the storage it's utilizing. So here are the two persistent volume claims that are in use. We can also take a look at the resources associated with this application. And here we can see config maps, the persistent volume claims, the pods that are being run, routes defined, and any particular secret that's associated with this application suite or project. If we want to take a backup, we can go over to the backup screen. Here we can see backups that have previously occurred. And so now we can see that we've done 3 backups in the past. If we want to do another backup, we would just select Backup Now. We would choose the backup we want to use. In this case, we only have one defined, and we would say Run Backup Policy. Once we click on that, a backup is initiated, and we can see that it's starting to do a snapshot. The snapshot, once it's completed, the system will then say running, and that means we're actually running the backup. And once it's completed, we'll get back to a green check mark, and we'll say completed, and we'll have yet another snapshot. The first snapshot or backup we take is a full. After that, everything is incremental forever. So that saves a lot of space on our remote environment. So we'll wait for this to complete, and once it's done, Then we'll go ahead and do a restore. Here we can see that our backup has moved from the snapshot phase to the in progress phase, which means it's writing the data from the snapshots it's taken and sending that out to our remote S3 location. Now we can see our backup is complete, as indicated by the green checkbox. We can click on that particular environment and see what we've taken, and we can see we have a backup. The backup has been named. It's a timestamp and the name of the project, the duration of the backup, the capacity we've backed up, and the number of PVCs. If we look a little more detail, we can see we had 2 VVCs and associated with it. One was the original PVC, one was a backup I've done previously, and that's associated with the project. Now I can take a look here and see that those are the PVCs that are associated with the project. Let's go into the data science project and let's take a look at it. We've got our license plate project here. We've got a storage associated with it. We can see the 2 persistent volume claims, plates 1 and plates 0 and plate 2. We can see the first one's in use, the second one isn't. So let's go ahead and do a restore, because let's assume one of those are corrupted. So we'll come back into our Fusion workspace and we'll hit the restore button. When we go and do the restore, we can select what we're going to restore. So I'm going to say we're going to restore to the existing project. Well, actually, we're going to do a restore in place. So we're going to restore to the same project, or we can pick one of the projects we have, but let's do it to the same project. We'll pick the backup we most recently did. We see there's 2 PVCs that it took a copy of. We only care about the first one, so I'll just unselect one of the PVCs because we just need the primary one. And then we'll go ahead and click restore. It confirms that we want to do that, and we say OK. Now the restore is in process. We'll wait a little bit and we'll wait for that restore to finish. Our restoration of our persistent volume claim is complete. We can see now within our project we have an additional PVC associated with it. That is the restore that we just did. And now we can come back to our application, and we see we have an additional persistent volume claim. And as we can connect to the original workbench, we can now create a new workbench connection. So essentially within our workbench, we're just going to start a connection here and attach it to our environment. We'll give it a folder name to mount. We'll call it restore. And now we've mounted that. When we go back into our workbench, we're opening up our workbench now, and we can go navigate to the additional mount point we just edited. And so here we look at our mount points, and here's our restore area, and we have another copy of our data. So here we can see that if we had an original copy of the data and we've had any kind of corruption, we can go ahead and just do a restore and bring us back to where we were.
This is what you get when you first connect into Rode. So here, for today's presentation, I'm going to act as a data scientist, a pure user of the platform, just to show you how easy it is to access those resources and use those resources for various use cases. So the first thing I see when I log onto the application is what applications are enabled inside the environment. And you can see different cards, different tiles here. We can see that we have some GPUs available. We have some toolkits from Intel, OpenVINO, or the AI Analytic Toolkit. We have something called Pachyderm, that's for data management, data versioning, lineage, this kind of thing. So that's an offer from an ISV. Or if we go into Explore here, you can see that other solutions would be available, either from partners or from Red Hat, or with various flavors being self-managed or managed by the partner. Many different things that you can add on the top of that. The one we're going to focus right now on is Jupyter, because that's the go-to solutions for most data scientists. So let's launch Jupyter Notebook and see how it goes. So here first, you see that you have access to different notebook images that are available. They each come with a different set of packages, of Python packages or OS packages, depending on what you want to do. Here, so of course, you can bring your own images into the application. That's very easy through one of the settings admin panel. Just import the image, and bam, you have it directly here. For this demo, I'm going to use a simple TensorFlow image. Okay, so we have some more information if we click here on the packages that are included, so we know exactly what we will get. Then we can choose a deployment size. So here, if I go on this drop-down, we have different sizes that are available: small, medium, large, X-large, with a different amount of CPUs and RAM, depending of what we want to do. So we'll keep it small for the moment, and we can also select a number of GPUs that we want to use in our environment. For the moment, I will select none. And then I just click on Start Server. That's all I have to do. I didn't have to install anything on my environment. In fact, I could do this from my iPad. That works exactly in the same way. What is happening behind the scene in my OpenShift cluster is that there is a new pod that is being spawned with the right image, the image that I selected, and it is reconnecting all my data to this environment, because of course all those pods, they are ephemerals, they are run on demand to save on resources, to make a much better use of the available resources in the cluster. That's how OpenShift is working. But of course, you don't want to lose any data from one session to the other. So this data is persisted on a volume that is automatically reconnected for you inside your environment. So after it is started, I can now open my Jupyter environment inside a new tab. So it takes a few seconds to start Jupyter. And I am now in my environment, and you can see that I have tons of different things that have been reconnected. It's part of my personal data that is there. I can show you, for example, a small project I'm working on as part of a new tutorial, a new workshop that I'm designing. It's for intelligent agriculture, and the purpose of the model I'm training is to recognize different sorts of disease in various types of crops, like wheat, rice, corn, and potatoes. Let's leave this one and stop this notebook so that I can show you another way of working within the environments. That is data science projects. A data science project in fact, translates to an OpenShift project, an OpenShift namespace. Okay, so that's a place, a fully isolated place where you will be able to run many different things. So let's head for my own project. And here you see I was seeing many different projects because I'm a full admin on this cluster, so I was seeing everything. But normally, as a normal user, you can only see the projects that you are allowed to see. Okay, so that's perfect for sharing the platform between different departments, different people. You can, of course, very easily give access to different users and groups for those different projects. So here in my project, I have different workbenches. Workbenches are, in fact, another name for notebooks, like for this data exploration workbench. If I was to edit it, you can see that I have selected a specific image, a container size, the number of GPUs. So it works exactly in the same way as when I'm launching this on-demand thing as we did first. And here, my data exploration environment is already running, and I can easily open it. And then again, I am in my Jupyter environment for this specific project. And in this project, I can show you what we have done. Here, it's training a model to recognize credit card fraud. Okay, that's a credit card fraud detection model. So here, that's my environment where I have trained this model to recognize if there is a risk of fraud based on different parameters that we will see. Okay, so that's my environment that I am able to launch. Of course, those workbenches are using some storage space. So here, that's what I can add, and I can add many different types of storage depending on what I want to do that I can plug directly inside my environment. What I can also add in a project are data connections. At this point, we are only supporting object storage. So it will be object storage. We're using the S3 protocol. So AWS S3 compatible storage, like Ceph storage, OpenShift Data Foundation, those kind of things. And we are using it to store, in our example, our credit card fraud model. So here, a data connection is simply all the information I have to know about how to connect to a specific bucket in my storage. Okay, so very easy to create. And the last part is the model server. So we have also this capability to directly serve models from inside the platform. So here I have an OpenVINO model server that is deployed, and on this instance, I have two models that are deployed. So here, my credit card fraud detection model, and if we look at the configuration, you can see that we have only to specify that, okay, this is a credit card, the credit card fraud model. It's running on the ONNX framework that is used. So that's a format to store a model. So that's what we indicate here. And that we use an existing data connection to tell the model server where we have stored this model. So here we are reusing the data connection that we have just seen a few minutes ago, the credit card fraud model, where we have stored the model at the root. Okay, so then again, very easy to serve a model. You just add here. I could deploy another model, entering all this information. Okay, this is the new location where I have stored my model, and bam, you have the model serving, and you have the address on which to connect to it.
Thanks for joining. If you like what you see, be sure to like, share, and subscribe. And as always, if you have any questions or comments, please let us know in the comments below. Thanks for watching. See you next time.